Now you've done it. You've asked my favorite kind of question. We're looking at the area of a triangle bounded by the x and y axis and the function 1 over x. So somewhere, anywhere along this line, I have the point 0, comma, y-intercept. And over here I have the x-intercept, comma 0. And here I have some x and y, any x and y value. Okay. You already know that the slope at any point on this line 1 over x is negative 1 over x squared, using the limit as the function goes to 0. So that's the slope of this line here, depending on where my x and y values are. And unfortunately, that's not enough information for us to calculate the area of that triangle. 1/2 base times height. I'm going to need more information than that. So if you remember, the formula for equation of a line is y2 minus y1 equals m times x2 minus x1. Well, I have 3 different points on here that I can use. And the first thing I'm going to do is I'm going to use this y here as y2. Then I'm going to use the y-intercept as y1. And the slope at any point on that line is this. And then the same corresponding x values would be x minus 0, right? Because my x value is x, and then because I used the y-intercept, the x-intercept, or the x value is 0, not the x-intercept. So I end up with y minus the y-intercept equals, these x's are going to cancel out, equals negative 1 over x. So y is equal to negative 1 over x plus the y-intercept. If I want to solve for this so that I have a value to plug into my equation, or some kind of a value other than the y-intercept, then y plus 1 over x equals the y-intercept. But then I have to think about, what does y equal? Well, if you go back to the original drawing, y is equal to 1 over x. So I'm going to substitute 1 over x for y because they are equal. And I can add these together and I get 2 over x is equal to the y-intercept. So I'm going to redraw that here so that it's neater. This is 0, 2 over x. And I still would like to have a value here for my x-intercept. So I'm going to erase this. Pause this if you need anything from here, because I'm going to erase it. Okay, and now I'm going to do the same thing again, only this time I'm going to solve for the x-intercept. So this time I'm going to use, let me find my laser here. This time I'm going to use this point here and this point here, so both intercepts, and I'm going to try to get some more information about the x-intercept. So for my second point, or my first point, y2, that's 0, minus y1, which is going to be my y-intercept, equals my slope from before, -1 over x squared, times the x-intercept minus 0, my y-intercept. Okay, and then we know that the y-intercept is 2 over x. So I'm going to substitute that. -2 over x equals -1 over x squared times the x-intercept. I'm going to go ahead and multiply everything by x squared because I want to get rid of the fraction crap. So I'm going to multiply both sides by x squared, and that's going to cancel that out. So I get -2x equals, and then that's going to cancel that, negative x-intercept. So if I divide both sides by -1, I get 2x equals the x-intercept. Okay, so that's this point, 2x comma 0. Now I have a base and a height, and when I calculate this, I get area equals 1/2. The base is 2x times the height, which is 2 over x. And you can see here that the reason this is always 2, I'm not sure if this was your question or if it was because I have to do things out. It's really hard for me to follow someone else's work. But these are always going to cancel out no matter what x is. And this is always going to cancel out no matter what value of x you put in. It's the unique nature of the fact that this is 2 over x and this is 2x, and you multiply it by 1/2, that makes the area always equal to 2. Hope that answers your question. Sorry, I'm really long-winded. I could have made this longer. Talk to you later. Bye.